Hello AP Stats. Here's our second summer work video on probability and inference, the last two topics we will go over this year in AP Stats. And for probability and statistics, we will only be studying those parts of probability that will help us answer questions about our data. For instance, suppose we had 100 students who took the SAT once, and then they took a SAT prep course, and then they took the SAT a second time. Say on average their scores went up by 50, but not all of their scores went up. Maybe some went down, maybe some went up more than 50 points, like 100 points. Wouldn't that be nice? So how do we know if that is statistically significant? And how do we know if, for instance, it was the SAT prep course that was improving their scores on average, or was it maybe just the fact that they've been exposed to the test a couple of times? So there's a lot of questions that we have to ask when we get our data, and probability is going to help us see how likely it is for some event to occur. So maybe we'd be able to find out how likely it is for a student's test score to raise just by taking it a second time and then comparing it to the results we got when we gave the course. So probability we're focusing on, remember, is the long-term chances of an event occurring. Perhaps the probability of getting a heads on a coin when you flip it is 50%, but that does not mean if you flip it 10 times you're going to get 5 heads. There's always going to be variability, and that's what makes statistics so interesting. Chance behavior is unpredictable in the short run. We don't know whether we're going to get a heads or a tails the next toss, but it has a very predictable pattern in the long run. And to show this, we're going to go to this app that's on our textbook website that simulates flipping a coin. So here I'm going to set the probability. Of course, it should be 50% chance to get a head or a tail, as long as it's a fair, normal coin. And we're going to toss it 15 times. So I'm going to push toss here. So notice I got heads a couple times first, and then tails, and I ended up with 9 heads out of 15 and 6 tails out of 15. So does that mean there's something wrong with my coin that it landed on 9 more times? When we think of what the true probability should have been, 50%, how come we're not hitting 50% every time? Because we're only looking at short-term outcome. Say if we toss it 100 more times, still we're getting many more heads, but as it continues on, we do seem to be settling down more to that 50%. Here, probability of heads is 4.96. Let's do it again 100 more times. When we're talking about probability, it's the short term that we're unsure of, but the long term does settle down to the true probability and is quite predictable. We use probability to determine how likely certain sample values or statistics are that we get from our data. What we want to know is this value likely to be due to chance? So if, for instance, scores went up on these SAT scores, is that chance, or was it caused by something we were testing? So here's an experiment we're going to do in class. Water everywhere. And we're going to take bottled water in 3 cups. Bottled water is a popular alternative to ordinary tap water, but can people really tell the difference if they aren't told which is which? Do you think you can tell the difference between bottled water and tap water? So I'm going to fill 3 cups with water for each student. 1 will have bottled water and 2 will have tap water. And we want to see if you can guess which one which one has the bottled water. So how can probability help us determine whether students can distinguish bottled water from tap water? Let's suppose that in another class, Mr. Bullard's class, 13 people out of 21 made the correct identifications. Well, this could have just happened by chance. I mean, if I put an X on the bottom of 3, I had 3 cups and put an X on the bottom of 1, but they were all 3 the exact same type of tap water, it is possible that 13 out of 21 could identify the one with the X every time just by chance. So it's a very important concept that you understand when we're looking at inference, when we're looking at probability with our statistics, is to see how unusual would it be that 13 out of these 21 students would guess right if actually there wasn't even a difference between the 3. How likely is it that as many as 13 of 21 would guess correctly? So we can figure this out by plotting a graph. Now this graph is not what happened in Mr. Bullard's class. This is what should happen in the long run. In the long run, since the probability of guessing correctly is 1/3, it should center at 7 out of 21 people should most likely get the right answer. And as you go further out, it's less likely that, for instance, 11 out of 21 or 2 out of 21 would get the right answer. But it is still possible. So this graph comes from a simulation. So if we simulated over and over the possible answers that people might get, we would get a graph symmetric like this. So right here I have an arrow on 13. 13 out of 21. That seems pretty unlikely. In fact, if we look at the probability according to this graph to get 13 out of 21 correct, according to this graph, would only be a chance of 0.0068, less than 1%, which is very unlikely. So what does that mean? Well, we might conclude that according to this data, it seems that in Mr. Bullard's class anyways, they can tell the difference between bottled water and tap water, at least for the type of bottled water they were given. So probability allows us to decide whether an observed outcome is too unlikely to be due to chance variation. Too many students were able to identify which of their 3 cups contained a different type of water for us to believe that they were just guessing. In effect, we tested the claim that the students were guessing. This is our first encounter with statistical inference. Notice the important role that probability played in leading us to a conclusion. And this is how we're going to be using probability in this course. So get ready to eat some M&Ms the first day of class and drink some bottled water and tap water to do some studies. See you soon.